guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at some of the conditions under which we can be able to compare these gas laws. Of course, we know that changes in pressure and temperature can be able to result in changes in volume of gases. And one of the aspects of gases we saw is that gases behave in a similar way irrespective of the nature of gases, especially when subjected to the concept of volume, temperature, and pressure. Now, in this case of standard conditions, these are going to assist us in trying to compare volumes of different gases when they have been subjected to these specific conditions. So therefore, we're going to give different or specific values for the temperature, pressure, and volumes, which basically refers to as the standard conditions that we're talking about. And these are going to be applied in these three sets of laws, or the combined gas law that we have talked about. So that's it. Thank you and welcome. So before we go into these laws, I'm going to look at a specific aspect that we have already talked maybe shortly in our previous videos. And this is the SI unit for pressure, which of course we have been giving it in different values of, different units of millimeters of mercury. And then we have talked about the concept of pascals and atmospheres. So this is depending on the different questions that we have dealt with in some of our videos, but I'm going to give the relationship between the three so that in any case we are required to do a conversion, it will be easier for us. So in this case, 1 Pascal, which is basically the SI unit for measuring pressure, is equivalent to 1 Newton per meter square. So basically from this particular dimension, we know that the definition for pressure is given as force over area, whereby the unit for force is newtons and the unit for area is meters square, which gives us this specific dimension for Pascal. So therefore 1 Pascal is equivalent to 1 Newton per meter square. And sometimes we refer to the units for pressure in atmospheres, which will give us an initial as HM. So 1 atmosphere is equivalent to 760 millimeters of mercury. So that's a conversion for that. Millimeters of mercury against the pressure. This is the equivalent units that we're going to give. So this one compared to pascals, it's going to be equivalent to, this is 101352 pascals. So therefore, which basically in terms of Newton meters can be given as, we have given an equivalent of Newton meters in pascals. So therefore for the last comparison, still it's going to be the same as 101352 Newton per meter square. So therefore this is a general relationship between the units that we're talking about for pressure. That's for atmospheres, millimeters of mercury, newtons per meter, and the pascals. So as we go ahead and trying to compare, in case we need to do a conversion, then we will be able to use that relationship that exists between those two different, or maybe 4 different aspects of describing pressure. So we can go ahead with our discussion for today and try to look at this aspect of standard conditions under which the laws are applied. Now for us, the standard refers to a universal way in which we can be able to do a reference or across the sciences and mathematics. When we talk about the concept of a standard, of course we have already talked about the concept of a standard unit, which are units that we use in doing reference. So we have already discussed that changes in both the temperature and pressure can cause a volume of a fixed mass of a gas to change, and therefore we can be able to do a comparison under same conditions of temperature and pressure using, of course, this concept of standard conditions by allocating specific values that are generally agreed as the standard conditions we can use. So we have 2 different aspects of these conditions, which is a standard temperature and pressure, and the second one that we have is room temperature and pressure. So if you are in a statement any of these two statements are mentioned, then we're going to allocate specific values that are going to be accompanying these specific conditions which we are going to use in case we need to apply the gas laws. So the standard temperature and pressure is given as, for temperature is 0 degrees centigrade, which is equivalent to 273 kelvins. That is for temperature. And the pressure is going to be 760 millimeters of mercury per 1 atmosphere. So that one applies to the concept of standard temperature and pressure. So the standard temperature for us is going to be 0 degrees centigrade or Celsius, which is equivalent to 273 kelvins, and the pressure is going to be 760 millimeters of mercury per 1 atmosphere. Now for room temperature and pressure, these conditions are going to be 25 degrees centigrade or Celsius, which is equivalent to 298 kelvins, and the pressure is going to be 760 millimeters of mercury per 1 atmosphere. So you can see there's a variation in especially temperature for room temperature and the standard temperature. So whenever I mention in a question maybe or something we require to find out standard temperature or room temperature, then we can be able to interpret that using these two specific statements that are mentioned on the right side of the board. So we're going to use a sample question in order to figure out how we can be able to find out the values given that standard temperature and pressure or something that is happening at room temperature. Yeah, that uses the lower section of the board. So I'm going to read a sample question so that we can be able to do it and figure out how we can be able to apply that specific concept of standard conditions under the gas laws. So the question says, at 27 degrees Celsius and 740 millimeters pressure of, so I repeat that, at 27 degrees Celsius and 740 millimeters of mercury pressure, a sample of nitrogen gas occupies 30 centimeter cubed. What will be its volume at standard temperature and pressure? So we're going to apply the first concept of standard temperature and pressure as the question states. So I'm going to extract the information that we have been given in the question so that we can be able to apply the gas laws effectively. So I can repeat again. The question says that at 27 degrees centigrade, which is temperature 1, and 740 millimeters of mercury, that is pressure 1, a sample for nitrogen gas occupies 30 centimeter cubed, that is volume 1. What will be its volume at standard temperature and pressure? So we can extract the information from there. In that case, the standard temperature is going to be that standard temperature that we said there, which is going to be 273 kelvins, which is equivalent to 0 degrees Celsius, but we use absolute temperature in this case. And then the pressure, the standard pressure, this one has been given in millimeters of mercury. Remember, we used the four aspects to describe it for millimeters of mercury, atmospheres, pascals, and newtons per meter square. So this one we have been given in millimeters of mercury, so we'll just refrain ourselves from using the other units apart from the one that we have been given. So for that case, it's going to be 760 millimeters of mercury for standard pressure. So we're being asked what will be its volume. So sorry for this. This is basically 760 millimeters of mercury. So we're being asked to find V2. And as I say, we just want to quote the combined gas laws. And this is P1, V1, T1, P2, V2, T2. So therefore V2 will be given as P1, V1, T2 all over T1, V2. And we're going to do a substitution for that from the figures we've been given. But first we have to convert this one to absolute temperature. Now this one, the first one is going to be at 27 degrees centigrade, this is going to be 300 kelvins, and the temperature too is already in its absolute value. So therefore we're going to do a comparison and do a substitution. So V2 is going to be, this is a pressure 1, which is 740. I'm not going to rate these units, so 400 and 740 because of space. So times V1 is 30 centimeter cubed times T2, 273 kelvins, divided by T1. T1 is equivalent to 300 kelvins times P2, 760 millimeters of mercury. So if we do a calculation for this is going to give us 26.58 centimeters cubed. So this will be volume 2 for this specific gas given this condition of a standard temperature and pressure. So for instance, it's for us just to do a substitution for this, having been given those. So in any case, if a statement maybe is missing, then we should know that if this, either this or this one is mentioned, then it's either referring to standard temperature or pressure. So the same case will apply to a question that states the statement of room temperature. So basically that's how we can be able to apply the standard conditions across these gas laws. So given a question or a challenge that is requesting us to use the same conditions, then it's going to be easier for us to do the same. I hope that this concept has been understood. So that is it for today. Thank you. Bye.